Have you ever tossed a ball into the air, watched it soar, and then seen it unfailingly return to your hand? Or perhaps admired the moon hanging steadfastly in the night sky? What invisible force governs these phenomena, keeping everything anchored to something else? Gravity is not just a force that pulls things down, it is a fundamental interaction in the universe. It is an intrinsic property of matter that causes all objects with mass or energy to attract each other. Gravity shapes planets, stars, and galaxies, holding the cosmos together in a cosmic dance. The core mechanism of gravity, as explained by Albert Einstein's theory of general relativity, is far more elegant than simple pulling. Instead of a direct pull, massive objects actually warp the fabric of spacetime around them. Imagine spacetime as a giant, flexible trampoline. When you place a bowling ball on it, it creates a dip. A smaller marble rolling nearby is not pulled by the bowling ball, but rather follows the curve in the trampoline created by the bowling ball's weight. Similarly, planets orbit the sun not because the sun pulls them directly, but because they are following the curves in spacetime created by the sun's immense mass. The greater an object's mass, the greater the curvature it creates, and the stronger its gravitational effect. Understanding this curvature helps us grasp gravity's influence. It means that gravity affects not just objects with mass, but also light, bending its path as it travels near massive bodies like stars or black holes. This phenomenon is known as gravitational lensing. We can observe gravity's effects directly in our everyday lives, from the simple act of walking on Earth to the complex orbits of satellites providing our communication and navigation systems. A fascinating detail in our understanding of gravity is the equivalence principle. This states that the inertial mass, which resists acceleration, is exactly equal to the gravitational mass, which determines how strongly an object interacts gravitationally. This seemingly simple idea was a cornerstone for Einstein's general relativity, showing that gravity can be thought of as simply being in a continuously accelerating reference frame, not just a force. Scientists are still working to reconcile general relativity with quantum mechanics, seeking a unified theory that might involve a hypothetical particle called the graviton. So, from keeping our feet firmly on the ground to orchestrating the grand movements of celestial bodies, gravity is a powerful and pervasive force. It is not merely a distant scientific concept, but a continuous demonstration of the universe's elegant design, profoundly influencing everything we experience and observe.